Triple bonds can be prepared in two ways. Both ways require the use of a dihalide, whether the two halogens are connected to two adjacent carbons or whether they are connected to the same carbon in there. And you have to use an excess of a base. The base needs to be a strong base. Avoid OHs and ORs and stick to nitrogen bases and bulky bases like LDA, like potassium tertiary butoxide, because those can favor the E2 elimination. So the mechanism is going to be an E2 elimination. Ammonia here, as we said, this is going to be a solvent just to mix the reagents together, and it ensures that the medium is basic so that the base can come and take the beta hydrogen and do the E2 elimination. So with these types of reactions, what you're going to end up having is a double elimination. Base is going to come. It's going to grab the beta hydrogen because here you have two beta hydrogens. And the beta hydrogens are going to be corresponding to the alpha carbon. So here you have an alpha carbon here, and this is going to be its beta hydrogen. And you do have another alpha carbon that carries the bromine, and this is going to be its beta hydrogen. So the idea here is that the base is going to come, take the beta hydrogen, form a double bond, and the bromine is going to leave. You're going to end up getting an intermediate. But the problem with this type of intermediate is that you cannot isolate it. So this intermediate here, you cannot isolate. This is why we call it an intermediate and not a product, because you cannot get that intermediate and stop the reaction. So another mole of the base will attack the beta hydrogen, form a triple bond, and the bromine is going to leave. So the process is going to be a double elimination in order to achieve your alkyne. When the halogens are connected to two adjacent carbons, then these are called vicinal dihalides. Vicinal is a term that we use whenever the functional group are connected to adjacent carbons. Triple bonds can be also prepped by dihalides, but now the dihalides are on the same carbon, and this is called the geminal dihalides. So whenever your functional groups, they belong to the same carbon, we use the term geminal. And it's the same idea. We're doing a double elimination in this case, and we are using excess of the base. It's an E2 elimination because the base is a strong base. So that base every time is going to come, take the beta hydrogen, form a double bond, and the bromine is going to leave. You're going to end up getting your intermediate, which is the double bond. You cannot isolate because that base is going to attack again. It's going to keep attacking as long as you have a hydrogen and the bromine to lose. So it's going to come attack again, form a triple bond, and the bromine is going to leave to get the alkyne. These are the only two ways to make triple bonds from dihalides. Another reaction that we use in order to prepare triple bonds is by alkylation of acetylene. So you start with the simplest form of a triple bond, which is acetylene, and you replace its acidic hydrogens by an R group. The reaction requires the use of a base to get rid of these two acidic hydrogens. You need to use excess of a base, two bases actually, in order to get rid of these two acidic hydrogens. And then you're going to form a nucleophile. That nucleophile will react with a primary alkyl halide, and you can alkylate both ends depending on what type of R group you need. That will be a substitution reaction. Remember, substitution happens best if we are using a primary alkyl halide. So the reaction starts as such. The first step, you have your base. The base is going to come and take the acidic hydrogen. You create your acetylide in this case. Don't forget that the acetylide is, we mentioned that the acetylide is a good nucleophile and a good base. We don't want it to act as a base. We want it only to act as a nucleophile. So this is why we are going to use it with a primary alkyl halide. To use it with a primary alkyl halide, it's a simple substitution reaction. So the nucleophile now is going to come attack the partial positive carbon. So it's going to attack the partial positive sp3 hybrid carbon. This is a regular substitution reaction. It's a one-step SN2 reaction, and it's going to kick out the bromine. There is no chiral center over here. So I'm going to conclude the second step by alkylating the first side of the triple bond. So you always look at the size of the triple bonds and see how many carbons do you need. So here I want 1, 2, 3, and 4 carbons on the side. So this is why my alkyl halide needs to include 4 carbons. It should be a primary alkyl halide so that the reaction will proceed with no elimination. If it was a secondary alkyl halide, then I would get the substitution plus I would get the elimination as well. So this is half of the reaction now, and I alkylated one side of the triple bond. I'm going to do exactly the same thing to alkylate the other side of the triple bond. So for the other side of the triple bond, I'm going to use another mole of that base, and I'm going to create my acetylide ion. And then I'm going to use that acetylide ion now as a nucleophile, and that is going to attack the alkyl halide. Now on the other side as well, I need my 4 carbons in there, or 3 carbons. So I need 3 carbons. So this is why my alkyl halide here needs to include 3 carbons. Don't forget that the nucleophile is attacking the sp3 hybrid carbon here. This is the partial positive carbon, and the bromine is leaving. And now I get my triple bond. Whenever you draw your triple bond, make sure that the carbons of the triple bond together with the adjacent carbons, these are supposed to be linear with 180 degrees bond angle. So if I want to combine all of these steps together, then this is what I did. In the first step, I used the base. In the second step, I used a 4-carbon primary alkyl halide. In the third step, I used the base again. And in the fourth step, I used the 3-carbon alkyl halide. So this is the sum of what I did over here, and these are the steps. So whenever you are given a synthesis reaction, and you are given the reactants, and you are given the products, and you're asked, go ahead and write down the reagents that you need in order to go from the reactants to the products, then this is what you need to write down. You can write the steps like this, but at the end you would need a summary of what you have used. Let's have another example here. Here I am starting with an acetylene, and I am only alkylating one side of the acetylene. This means that the other side here, it's still an acidic hydrogen. So this side here is an acidic hydrogen. I'm just going to go ahead and keep it. And the other side here, let's say, this one, I'm just going to go ahead and add an R group to it. So I'm going to take my base now, and I'm going to allow that base to come and take that acidic hydrogen and create the acetylide. So you form your acetylide. This acetylide is going to act as a nucleophile. And the R group that I need here is made up of 1, 2, 3, and 4 carbons. So this is my 4-carbon primary alkyl halide. It's going to go by an SN2 reaction. So my nucleophile now is going to come and is going to attack. So this one is going to come, is going to attack the partial positive carbon. Bromine is going to leave, and I'm going to end up alkylating my triple bond. So here I reached my product. So in this step, I reached the product that I want, which is this product over here. But the problem is that my medium is basic. And as we said, that the base is going to keep reacting as long as there is an acidic hydrogen. And here I do have an acidic hydrogen, and the acidic hydrogen is over here. Whether I'm using the base in excess or not, my medium over here is the NH3. And ammonia is a base. So that is going to ensure that the NH2 now is going to come and it's going to attack the acidic hydrogen in there and create the acetylide again. So this is why whenever I have a terminal triple bond, I'm always going to use the base in excess because the base is always going to be in excess. This is why I need an additional final step to make sure to gain that acidic hydrogen back again, which is the water. So water is a must to use every time I have a terminal alkyne. That excess base is going to take the acidic hydrogen. So all what you need to do is just to throw in some water in there. And that water is going to act now as an acid from the hydrogen. So this one is going to act as an acid. Of course, it's not going to be a strong acid, but this is going to be a base. And this is a good base. So that base is going to come and take that weak acidic hydrogen in there. The OH is going to leave. And as we said last time, OH is a bad leaving group unless you have a sodium counter ion in the solution, then it can couple with a sodium in there. Now I can ensure that I have my terminal alkyne once I throw in some water. So this is going to be the last step, and we use this every time we have a terminal alkyne. Notice that I didn't use water in the example before because I don't have any terminal alkyne as a product, but here I do have a terminal alkyne. This is why I need to use the water. We can prepare triple bonds from double bonds. And every time you want to prepare a triple bond from a double bond, remember the elimination. Remember the E2 elimination and remember the dihalides. So you need to have dihalides and you need to do double E2 elimination to go from a double bond to a triple bond. And the reaction goes as such. So here I am not changing the number of carbons. Notice, I need to prepare starting from one hexene. So starting from a 6-carbon alkene, I need to prepare a 6-carbon alkyne. So we're going to start with our alkene. And the only reaction that we know that we can add to the alkene is the bromination or the chlorination. So we can use either Br2 or we can use Cl2 in there. And we're going to form the vicinal dihalide. Once you form the vicinal dihalide, we can perform the reaction that we explained above by double elimination. So you're going to use excess of the base in there, and you're going to do a double elimination. Every time the base is going to come, take the beta hydrogen, form a double bond, and the bromine is going to leave. The second one is going to come, take the beta hydrogen, form a triple bond, and the bromine is going to leave. So I'm going to end up getting my triple bond. But notice that since my triple bond that I am forming is terminal, then we're going to say exactly as we said before that the medium is basic. It's so hard to control the base in the solution. So the base is going to attack as long as you have an acidic hydrogen. So here I'm going to use a 1/3 mole of the sodium amide to take that hydrogen and form the acetylide. This is why I need to throw in some water to have my acidic hydrogen back. So the overall reagents that I used in order to go from a double bond to a triple bond, I didn't change the number of carbons. It's still 6 carbons. I added the bromine first. I brominated. I did the E2 elimination over here. And then the base is going to come take the acidic hydrogen, and then we added some water in order to regain the acidic hydrogen of the triple bond. These are more examples that you can go over. So let's say, for example, now if I give you an alkyne and I ask you go ahead and make that alkyne. So you are going to pick up the acetylide ion and you're going to pick up the alkyl halide that you can use. Make sure that the alkyl halide that you pick is a primary alkyl halide. So you're always going to start to break the bond that is connected to the triple bond. And then stick a halogen there. Make sure that it is a primary alkyl halide and count your carbons. So over here, I do have 1, 2, 3, and 4 carbons. This is a carbon in there. So this is going to be 1, 2, 3, and 4 carbons. This is a primary alkyl halide, so I can use this side to be my alkyl halide, primary alkyl halide. And the other side over here is going to be my acetylide. And this carbon over here is going to be my nucleophile because it's this carbon that is attacking the partial positive charge and kicking out the bromine in order to make this triple bond. So this one is going to be now my alkyne, and my alkyne is terminal because the alkyne has a hydrogen, and this is the hydrogen. So this is one possibility here because my alkyne is terminal. However, if you have your triple bond internal, meaning that you have two R groups in there, then both R groups can be an alkyl halide in this case. This one can be the alkyl halide, or this one can be the alkyl halide. So you're going to end up getting two ways in there in order to prepare this alkyne. You are going to break the bonds that are being connected to the triple bond and stick a halogen to this carbon over here. So now I'm going to end up having 1, 2, 3, 4 carbons and a halogen. Okay, this is a primary alkyl halide, so SN2 can happen. It needs to be primary or a methyl halide. So with methyl halides, also the reaction can happen. This is an SN2 reaction, and it can happen. So if this is a primary alkyl halide, then this whole part is going to be the acetylide. Just write it down. Or if you break this bond over here, then this is going to be my alkyl halide over here, and this whole part is going to be my acetylide. Also write it in there. These two methods we can use in order to make this internal alkyne. On the other end, if we have a tertiary R that is substituted on the triple bond, pay attention, you cannot stick a halogen to it. So you cannot prepare it by an SN2 reaction because there is not an SN2 reaction in there. This means that there's only one way to prepare this triple bond, by only breaking this bond, sticking a halogen in here. So you will have a primary alkyl halide, and again, pay attention to your carbons. You have 2 carbons in here, then you need to end up having 2 carbons in there. And then the other part is going to be the alkyl acetylide.